Are we live yet? Okay. Hey everyone. Hey, thanks for joining in. Can you just confirm if you're able to hear me properly? Hello. We do have four people joining us live. Thank you, Bharat, for confirming. We'll just start shortly. I'll just wait for 1 more minute. I do have two monitors, so I just have to check the particular screen. Okay, it seems we are nine people joining us live. So what I'll do is I'll start with the session. So before we can proceed, a quick intro of what we will be doing today. So we'll try to understand how Uber built their AI agent, and they termed it as Genie, right? And this is particularly episode one of engineering blog article series, where what I will do is I will break down how you can start building certain case study project as your projects that you can add in any GSOC proposal or also in your resume. Because in last few days, I've given way too many talks on PyCon conferences and also other places. And one common question was what kind of projects to build in AI. So if you're a AI researcher, probably you'll have to replicate papers. But if you're someone who wants to get into the development side, it's better to understand how companies are using AI and how they are building it. So this is the motivation of this particular series. So we will start with Uber, where we'll try to understand how to build an agentic RAG. So there are few critical components in their entire architecture, which we will try to decouple and understand why they took that approach, right? So we will follow the same procedure for the other use cases as well. And I know there are few questions that you will have, but I'll cover all the questions that you have. So a little bit context, because I know there are few people who have joined us for the very first time, right? To those people who don't have context about who I am. So I'm a founding engineer at a Luxembourgish company. Currently, we are in the beta version. And apart from that, I also share content on our channel, which is Yeah with Tarun. And I'm part of Google Developer Experts program, where usually I share talks related to Gemini and everything that revolves around LLMs. And I'm an active PyCon speaker, mainly in the APAC region, which covers Hong Kong, Malaysia, Singapore, and Indonesia. And apart from that, I love contributing to open source. I've been part of GSOC for 2 consecutive years. And in 2024, I was part of Red Lab. And in 2023, I was part of CA Microscope. All right. So what we will do today is this is the engineering blog article that we will replicate. And the title of this blog article is Enhanced Agentic RAG. What if chatbots could deliver near human precision? So, what we will do is we will try to understand their architecture and decouple what we are supposed to build. So, before that, I'll share some important points. I want this entire session to be very interactive. If, in case, whenever you see any slides or whenever you see any code component, if that doesn't make sense, what you can do is you can just add your question. I have two monitors that I have. So as soon as I see any question, if I feel that is very important, I will take that question automatically. If not, I will wait for some time and then pick that question. So let's try to have it roundtable. If you have any issues or if you have any suggestion, let's suppose I take one approach or whatever architecture that you see on Uber, and if you think you have some better alternative, try to share that information so that anyone who is joining us live, they'll get some kind of information, right? And second thing, as I said, this entire case study series is pure initiative on how you have to build projects referring to the case studies, right? So what tech stack we use might be different than what Uber has used. So Uber is using LangGraph, which they have confirmed, but there are other component as well, like what embedding model, what LLM model, then what vector database, which they have not shared. So when we are building this case study projects, right, not just episode one, also episode two, episode three, whatever tech stack we use, it might not be relevant to what the Uber is using, but the entire architecture is something which is relevant. So we will be using those, right? So just to want to clarify, whatever we use might not be necessary that that tech stack is being used by Uber. The only one confirmed thing is LangGraph. Apart from LangGraph, we don't have any information related to LLMs and embedding. All right. And the second third most important point is we will try to build the prototype, but the most of the research concept that you have in order to understand that architecture, I will take that upon myself, and then I will try to break down that in terms of prototype code. And then what you guys can do is you can build upon that and then share it across your resume. And all right, so this is just the starting. And as I said, we have few more case study projects. I'll just give one clue. The next case study projects will be related to text to SQL sequence, right? So this is very important case study, which I will not reveal what company name. I will only reveal that after this particular session. And coming to the last point, before we can get started, do join our Discord server. If in case you have any questions after this session, you can interact with me and with the community in the Discord server. And don't forget to subscribe now. And to this question, Sayan, you will be getting slides in the description of this video once the live session is completed, right? So the slides will be available to all of you. So after the session, you just have to open the live session link, check the description. You will have the code, and you will also have the slides URL. Okay, so let's begin with the particular session. To begin with, this is how the entire architecture looks like. And what Uber has done is they have built a Slack chatbot, which is Genie. And in order to build this particular chatbot, they have their own knowledge documents. So this knowledge documents basically are nothing but the policy documents, which has been stored by the Google, in the Google Drive. So what we will do is let's try to decouple every single component rather than seeing the entire architecture at once. It's better to understand every part one at a time, right? So first thing is we have two components. The first component is offline document processing, where you save your data inside a knowledge base. And the second component is answer generation, which is happening real time. So the first thing is let's try to understand in the offline document processing, how do you extract the raw content from the given PDFs or documents? So this is where there is a nice quote that you have related to ML. The quality of the model depends on the quality of its assumptions and the quality of its data. So to those who have learned machine learning, you might be aware that, okay, model building is just a single part. But whatever data pre-processing you do, that takes too much of time. And in order to process your data, you need to be a domain expert. You need to have a proper quality of the data that you have. So this is where whatever raw content that you extract from the PDF, it's very important. Let me give you one edge case over here. Let's suppose you have a PDF. In this PDF, you have a table, and in the table, you have a value called 25 degrees Celsius. Okay, so you have a PDF, you have a table. In that table, you have 25 degrees Celsius value. Now, when you're using any extractors, let's suppose you're using any PDF extractor, whenever you check the table information, the 250 degrees Celsius is sometimes converted into 250. So that degree is converted as 0. So when you are passing this information to large language model, it will hallucinate. And if it hallucinates, whatever application you build will not have that much of value, and not many people wants to use it. So this is where having a proper quality of data extraction is very important. So there is one research paper, and there are also a few of the loaders that we can use in order to build it. But let's try to understand how Uber built it, right? So the problem statement was they experimented with different loaders. As I mentioned, Uber is using LangGraph. They're not completely using LangGraph. They have customized it and they made their own framework, which is called LangFX. So in there, you have different loaders. You have PDF Plumber, then you have PyMU PDF, and then from Llama Index, you also have Llama Parse. So these are some of the parsers that Uber had experimented. And in most of the cases, they were not able to extract most of the information well. So here is what they did. First thing is, you have a PDF, you convert that PDF into Google Docs format. So when you convert this PDF into Google Docs, you have an HTML formatting which can later be converted into chunks. So if you see here, to address this challenge, they converted PDFs to Google Docs, and then using HTML formatting, they have more accurate text extraction. So when you have HTML format, raw text, it's easy to extract, but also whenever you have any tabular column data, it will also extract well if your data is in HTML. And lastly, once you have your data extracted, you have to convert that HTML into text and also use the chunking approach. So this is where you have something called as HTML to text library. If not, you also have Markdownify. So what we will do is we will experiment with Markdown, which is one of the library that converts your PDF format into Markdown format, and not just PDF. Whether you have docs, whether you have PPT, you can convert that into Markdown format. I'll show the code. We have the experimented code as well, so I'll share that shortly. All right. So here is what we will try. As I mentioned, we will be using Markdown to directly convert our PDF into MD file, which is very similar to what Uber might have done. I can't say exactly what specific library they used, but since they mentioned they converted their data into Google Docs and then HTML to a text file. So Markdown also does something in similar. And after multiple experimentation that I have done across multiple data loaders, I just found out llama parse. Then there is something called as PyPDF2, unstructured loader, and doclink. So these are four libraries or four loaders which extracts your tabular data pretty well if you're using PDF data, right? So here is some understanding, or here are some of the benchmarking. So if you check this particular paper, which is called drxiv.org, so let me quickly open this paper. So the paper name is The Comparative Study of PDF Parsing Tools Across Diverse Document Categories. So in this paper, they have experimented with different segment or different domain. That domain includes financial, law, manual, patents, and scientific. So in this experimentation, if you see, there are different kind of parsers. You have PDF miner, then you have PDF plumber, then you have PyMU PDF, then you have a simple PyPDF loader. Then here, if you see, you have something called as PyPDF, PyPDFM, and then you have unstructured loader. And if you look across all these sections, you will see PyPDFM has more scores compared to any other loader. And even I experimented with all the parsers. I'll also share you the collab notebook so that you can test it out as well. Let me quickly open my VS Code. So if you see, this is the code that I'll be sharing after the session. Inside notebooks, you have something called as document parsing testing. Here, what I've done is I've tested with every single PyPDF loader that we have, whether it is PyMU PDF, then you also have OCR based. Then there is something called as Open Parse. Then you also have PyPDF Plumber, and then you have unstructured IO. So I've tested with all of them, and there are results in this particular Collab notebook, which will be available publicly after this session. So this is the results, and as you can check from this particular paper, they found out PyPDFM having more score across multiple PDF categories, whether it is financial, law, manual, or scientific. Since the problem statement of Uber is something related to policy documents, obviously the safer bet is to go with financial and law. So this is the reason why in our code implementation, we will be using this particular loader. All right, I hope that makes sense, and probably will proceed next. So this is one interesting thing you have to notice. Loading your data is fine. You have your PDF, you're able to extract it, then you convert that into HTML, everything is good. And what happens next? How do you improve your retrieval process? When it comes to retrieval augmented generation, you have two components. One is retriever and one more is generator. You have to ensure if your retriever is able to extract good information or not, right? So when you have to extract a very valid information, you need to pass more context. So this is where what Uber has done is, once you extract any data on the chunk level, what they're trying to do is they are creating document summary of entire document and adding that as a one single key. Then they also have a chunk level summary, and then they have frequently asked questions, and then the keywords. So let me show you the format. I'll open my drawing board. So if you have worked with LangChain, you know by default your metadata includes, you have source, which is nothing but the file path. Then you have page number, which will be 0 to whatever your data is about. So if you see, this is the standard format what metadata includes in LangChain as soon as you use any PDF loaders. Now what you need to do is, in the custom metadata, you have source, which is nothing but your file path. You have page number, which is 0 to whatever data you have. And then you have document summary. So this document summary is for the entire PDF that you have, and this will be repeated across all the chunks. If you have 10 chunks, 10 every single chunk will have document summary. So document summary will be appended across all the chunks. And then for every chunk, which is each chunk, you also have chunk ID. Now, why is chunk ID important? Because usually, let's suppose I have a data is total 10 PDFs. Now, if I ask any question, I want to know from which PDF it was extracted and from which chunk I was able to extract that information so that I can get a valid page number. But I also need to extract chunk ID so that I will able to map it properly. So chunk ID is very important for mapping and as well as filtering. So this will be on chunk level. For every single chunk, you will have a unique chunk ID. And then you will also create chunk FAQs. So here what Uber is doing is, if you check their engineering blog article, below the diagram, if you check here, this enrichment metadata, okay, it's here. We incorporated document summaries. So this document summary is for all the chunks, it will be same. And then it also has something called as FAQs, which is frequently asked questions and relevant keywords. So this is added for every single chunks. Okay. So now chunk FAQs and chunk keyword is for every single chunk, and this can be different for every chunk. FAQ can be different, keywords can be different, but document summary will remain the same. So this is what we will be adding. We'll add document summary, we will add chunk ID, we will add chunk FAQs, and then we will add chunk keyword. So why is this required? Since we are using vector database supports vectorization of your data, and also you can add metadata into the payload, which can improve the performance of your retrieval. And you can also do filtering, and filtering can be based on the keywords, or it can be based on the locations, or it can be based on the source. Let's suppose you have 5 PDF documents, and now user is asking any question. This question has any overlapping between 2 different PDF. So what you can do is you can give flexibility for the user to pick from which source you want the information to be extracted. So this source is your metadata, and if you want user to filter it out based on the source, you have to add your metadata into the payload. So this is where vector database is also very important. And in order to improve the performance, we will be using hybrid search, which will do vector search, which is nothing but cosine similarity, and then you will also perform keyword search, which will mainly use BM25. And whatever I'm mentioning it here, it's as per their architecture as well. So if you check their architecture, if you see, once you save it in a vector DB, you want to perform vector search, and also you want to perform BM25 search. So we have to also enable this particular block, which is usually happening via vector database. And now if you notice here, sometimes you also need to process the queries based on the metadata filters. So how to add this filter condition, I will show that via vector database. Filter condition for the retrieval. Okay, does anyone have any questions? So far what we are trying to do is you have PDF data, you're converting that into HTML or Markdown format. We'll try with Mark it down, and I will also show PyPDFM. The reason why we are using PyPDFM is because of the benchmarking that is mentioned in this particular paper. So we want to also replicate how this paper has the benchmarking scores as well. So we'll try with this particular approach. And as I mentioned, you do have the code for all the loaders which have experimented. After the experimentation itself, I'm going with this particular loader. So the data and code will be available to you. And after that, once the data is extracted, you need to have metadata filtering. In metadata filtering, you will have document summary, which is repeated across all the chunks that you have. And then for every chunk level, you will have chunk ID, then chunk frequently asked questions, and then chunk keywords. So this will help in metadata filtering for better retrieval. And then for retrieval, we will be using hybrid search, which is the combination of vector search and keyword search, where we will be using BM25. So the filter condition and as well as hybrid search, we will use Qdrant vector database. So from Qdrant, we can perform hybrid search and as well as save the metadata into the payload. Okay, so this is mainly it whenever it comes to so as I mentioned, once you have your data extracted, then you have the table summary where we are having our own custom metadata. And once that is done, I've already told you why we have to save a custom metadata. So all these things, whatever I mentioned so far, is what you will be doing in offline document processing. So what do you mean by offline, right? So there are two keywords. One is offline document processing, and one more is real-time answer generation. When you are building any application, you want data to be saved in vector database in the offline mode. That means user will not upload any data. You have to save data manually, which is separate than your main application. Now in the main application, you will let user ask any questions. So this is where you will have answer generation. And for answer generation, we will be using Streamlit. So I've already created a Streamlit app where you can ask any questions and get the response. And also the code for Streamlit will be available to you guys. The notebooks, the Streamlit code, and as well as the logic will be available on my GitHub repository. And we will maintain same repository for all the case study projects, which we will be doing in this series. So you can check it out after the session as well. So this is our app. Now, when we come back to the architecture diagram, now that we discussed about offline document processing, if you look at the answer generation part, Uber is using their own Slack interface, right? So they build their own Slack chatbot instead of Streamlit. So if you want to experiment and if you want to build your own agentic RAG for specific endpoint, either you can build it on Slack interface, which is your Slack chatbot. If not, you can have Fast API plus React app. If not, you have Streamlit. If not, you can build it on Discord chatbot. It can be anything, right? So where you want to retrieve the information, this is where you do inference. I ask question, I get the response. So you can use any application for that, whether it is any chatbot or whether it is a Streamlit UI. It doesn't make sense, right? So you can use anything wherever you want to inference the data. All right. So now if we talk about the answer generation part, one major thing what we have to notice here is they're running multiple LLM calls. As soon as user asks a question, they want to ensure that the LLM query, whatever a response is entering, it has to be optimized so that when you retrieve any information, it makes sense, right? So this is where we also have to build this query rewriting agent where user asks any question based on the input variables, you will improve your query optimizers. And once that is done, you will apply your filtering condition, and then your retrieval will give you the retrieved chunks. And once you have retrieved chunks, you have your final answer generation where we will be using LangGraph. And regarding this pre post processor, I'm not that much of sure what Uber has done. So we will be skipping this particular part since I don't have much clarity on this. And since most of the code is available on GitHub, once I complete the code demonstration, if anyone is able to know what this post processor is, you can create a good first issue, or you can also create a PR. That way we will know, okay, this particular pipeline makes more sense, right? So what we will do is we will replicate this. Can you explain? It mentions small on the agent part. Okay, so when it mentions small, in the sense, let's suppose you can use any small LLM models. For example, if you are using LLM large, you will use OpenAI. If not, you'll use GPT. So in GPT, if you need better responses, you will go with GPT 4.1. And small is nothing but you have to use lightweight models, which pricing is very low. For example, GPT 4o mini. If not, you can use any lightweight open source models, which is 5 3.5, right? So small, nothing but whichever LLM model has lesser parameters. uh, GPT 4o mini has very less parameters compared to GPT 4.1. So for large, you can use GPT 4.1, and then for small, you can use GPT 4o mini. Same goes for Gemini. So here you can use Gemini 2.5 Pro. Here you can use Gemini 2.5 Flash Lite, which is a lighter model. So small in the sense, the lesser number of parameter models. Okay, so if you see for query rewriting, they are not using any better models. They're just using any models which can just rewrite the query that a user asks based on the source metadata that you have. And based on that, now you have an improved query which is going to the retrieval. And once you have the retrieval, you have the retrieve chunks. Post processor, they have not mentioned anything in the blog. So what we will do is we will skip this part and directly build the answer generation. So this will be our entire pipeline. But now if you notice the architecture, we discussed document processing. We understood, okay, we need to create custom metadata, we need to have proper extraction using good PDF loaders, and once we save it in vector database, we can also perform retrieval. We have answer generation. Here you also have one interesting part, and this interesting part is how do you evaluate your entire RAG pipeline, right? Evaluation is also very important. So if you see, it's separate. So document offline processing, you're doing it manually. Then you expose your inference endpoint to the users so that they can chat with the existing chatbot, either using Slack bot, or it can be Streamlit, it can be any web app, right? And now what you have to do is, once you have real-time information that a user asks the question, you have to create a data set for it so that you can use it for evaluation. So for evaluation, we have something called as LLM as a judge. So there are only 6 LLM as a judge. One, you have relevance, then you have answer relevance, then you have groundedness, and then you have ground truth, and then you have faithfulness, and then you have correctness. So we have already created a complete live session on how to build what you call how to build the evaluation pipeline. So this was the last live session that we had done, where most of the people had joined live, and we also discussed how to build the metrics based. So usually when you're evaluating your RAG pipeline, most of the people try to use LLM as a judge, like rank the response from 0 to 5, which is wrong. So usually you need to have a binary approach. If the response is there in the context, just say true or false. So this is where we also discussed in detail why we have to use that approach. So what you can do is you can check out this live session that we did last week. You will get more clarity, and also the code is available in the description. And to more, what you can do is you can check out this article, which is creating a LLM as a judge that drives business result. In this article, it is clearly mentioned why you have to go with binary approaches, which is true or false, pass or fail, instead of ranking based. So the ranking based is nothing but whatever you see in the screen, right? So I'll share this URL. How chunk keywords metadata is known at the time of chunking, slightly elaborate on that. So when I mentioned this thing, right, uh, usually you just have source and page number, document summary, chunk id, chunk frequently asked question, and chunk keywords will be generated by LLM. So we will use LLM to generate this particular metadata. So we already have the raw data. That raw data will act as a prompt, which is your context. And based on that context, we will use LLM, which will generate the relevant chunk keywords and frequently asked question, and as well as the document summary. So for document summary, either you can use something called as text re-rank, which is a text summarization technique. But for this prototype, in our live session, we will be using an LLM. We'll use the smaller model itself, which is 8 billion parameter model, and it will be Llama model. Your question, will be using LLM to generate the chunk keywords. Okay, so this is on the evaluation side. We already have the code available for evaluation, and we also have the complete live session. If you see, it was around 90 minutes that we conducted the entire live session. So you can check out that particular session along with the code. All right. So now coming to the future works and improvements. If you look at the framework, right, whatever these guys have tried to build, there are many flawed. I mean, there are many improvements that can be done, and especially on the generator side, there is not much valid pipeline that they have. And if you notice one more thing, the major thing is this part. When you convert your PDF into Google Docs, you can't have any multimodal, right? So basically, if your data is converted into Google Docs, it is only textual data. You can't build any multimodal. So the major issue with their entire pipeline is there is no OCR support. So whatever we do today, it's mainly textual data, and the same needs to be extended and extract on the multimodal content, including the images. So why am I adding this future work? Because you build the prototype, and if you want to build something additional to it and add it in your resume, that will make more sense. And if you want to pitch that particular product to any interviewer or any hackathon, you will have more what you call, you will have more impact in that particular project rather than the project where you're just copy pasting. So most of the projects available online, it is very common, right? You will see same projects in resume, like recommendation system, simple chatbots. Now if you look at this particular approach, you're building your own custom metadata, you're building your evals pipeline, and you're also building a hybrid search approach with binary quantization. So this way you have multiple optimization technique that you will learn while building case study projects. And for every case study projects, if you look at their blog articles, right, they will have future work. So just scroll down, and if you see here, they have next step. And in this next step, they have clearly mentioned the same can be extended to extract and enrich multimodal content. As of now, they don't have any multimodal. So the OCR support is missing just because they converted that into Google Docs. And second thing is, they want to improvise their step by step answer generation. So answer generation usually needs two things. One is you have single op questions, and then you have multi op questions. Now, what is the difference in this? Let's suppose I ask any question which is just X prompt, and what this X question will do is it will go into vector database, it will retrieve the information. Now this is single, this is straightforward question. Now what you mean by multi-op is you have X question, along with that you also have a Y question. Now in the same prompt, you have two different questions which need multiple chunks. So how to handle multi-op question is also very important. So this is where they still don't have that approach. So if you see, for multi-op reasoning queries, they want to experiment with chain of RAG, which is still yet to be done, and they have not built it yet. So if someone who will be building after this particular live session, we have the prototype, and if you want to add more changes to it, you just have to add OCR support. You need to have chain of RAG, and then you have a project that you can showcase in Google Summer of Code, or you can showcase in your resume. And after that, if you notice one more point, as of now, they don't have any tool support as well. Let's suppose lots of policy documents is available, which is in internal tool. You have a tool which is knowledge base. And if you need to extend the tool support, like do search, have code executor, have calendar, or any API or custom API tools, they don't have any tool support yet. So what you can do is you can also have agentic RAG, where if the question is from the knowledge base, extract it from knowledge base. If question is not in the knowledge base, it can use search, right? So this is where it should have LLM powered agents that can choose tools based on the user query. So these are the three major areas where someone can improve this particular use case and build something very useful, right? Which will make more sense when you add it in your resume. And if you want to build this, we already have a video on it. So if you check this videos, here you have a video called How I Thought AI Agent, when to use search and when to use vector database. So here basically you have a router agent. Whenever I ask any question to the router agent, it will think, is it in the vector database or should I use search? Based on that, it will use the specific tool. So now you know what is the architecture. Now you also know what are the areas you can improve the pipeline. So what we will do is we'll start off with the code demo. And once we start with the code demo, I'll set you a proper prototype, and after that prototype, you can try to build upon that so that you can have it in your resume. So all the code is available on GitHub. What I will do is let me just push that particular code. So I'll just add git add Uber Agentic RAG. You have notebooks. Then git add, you have app.py, and then you also have requirements.txt. So this should do for timing. Let me push this code. Prototype of Uber Agentic RAG. Push. And now if I open my okay, it's not pushed yet. Okay. So as I mentioned, when I was working with this document extraction part, since I didn't add any Google API, Google Docs API keys, what I did was I went to a research paper. This research paper was how you compare PDF, different PDF parsers, and which one performs better. And during that time, I just found out PyPDM to be better. And during this experimentation, I also had a collab notebook, which I'm making it publicly available. So if you check out this particular repo, you have notebooks. Inside notebooks, you have experiments. And inside experiments, you have document parsing testing. So this particular notebook, as the entire code, it's pretty lengthy. There are so much of experimentation that I've done across multiple PDF parsers. And apart from that, you also have offline document processing, which I'll show now. And you also have inference answer generation, which is mainly for the answer generation part where we are using LangGraph. And then in the same code, you also have evals. Let me check this code. So if you see, first we have the answer generation part. And once you have the answer generation, I also have the evals where you can create your own data set. So if you see, we created our own data set. How? If you check this particular URL, which is Uber Agentic RAG, they also have something called as golden test data. So you need to generate your own test data as well, which I've done. And let me share this URL so that both of us can try the code demonstration live. I'll start with offline document processing. Then I'll go with answer generation. So this is the GitHub URL. You just have to search for github.com lucy4trj, and then you have case study series, and inside that you have Uber Agentic RAG, and then you can check out the notebooks. And in the notebooks, first we will try with offline document processing. All right. So let me come back to the code and let me start with the installation step. And as I said, I'll be using PyPDFM. And then in order to use this, I will directly use it from LangChain community and LangChain for the schema part. And for the vector database, I will be using Qdrant client. And then for embedding creation, I'll be using fast embed. And for the smaller LLM model, I'll be using LangChain Sambanova. So as per the blog, we have one small LLM and one we have large LLM. So for the large LLM, I'll use Gemini 2.5 Pro. And for the small LLM, I'll just use Meta Llama 3, Meta Llama 3, which is a 8 billion parameter instruct model. So the installation is done. I will not run the entire code. I'll just break down every single code and why I've written that particular part. So the first part is I wanted to experiment with Marketdown. So what Marketdown does is it's an open source framework. If you upload your any data, which is in PDF, docs, or PPT, it will convert that into a markdown format. So the syntax is very simple. You just have to import from Marketdown, import Marketdown. And then since you don't have any enable plugins, for example, if you are using Marketdown, there are tons of plugins available, but by default, when you install the library, there are no plugins. So that's the reason why enable plugins is false. And you don't need plugin in most of the cases. Only when you have OCR or if you need any customization, then you can have enable plugins to be true. So you just have to search for this on the GitHub issues or GitHub topics, and you'll get few of the open sourced enable plugins. And once this is done, once you have your MD object, you just have to use .convert. And once you use convert, you can add your PDF that you want to convert it into Markdown. Let me just try it with one of the file. I will not upload my actual data that I have saved in the vector database for time being. Let me upload a file. Okay, so now if you see, I have, let me install this as well. So we'll start with Marketdown, and once Marketdown is done, we'll be using PyPDF from. And here, I'll use content, the particular data path. And now, if I just print on test content, if you see, if it has any text content, it will convert that into Markdown. And if you notice one more thing, after every single page, it is adding this particular line, which is 11, then page. And if I scroll above, it will have 10 and then page, then 9 and the page. So if you notice, it is extracting even the bullet points. Then here you have 8 and page, and then you have 7 and page. So this way it is able to extract most of the content. And if you check this particular repo, Marketdown, within just 9 months, it was able to reach 72.5k stars. And this is really incredible. You just have to try this. And if you have any plugins, try to add plugins and improve the performance of the data extraction. So this is one thing. And apart from that, we also have one more document processing. And that the second document processing is PyPDFM. So now if you see, I have a data folder. So when I created vector database and saved my data, I had around 6 to 7 PDF files. And what I wanted to do is I saved all the files inside a folder called data. And then I just had to parse it entirely using PyPDF parser. And now once this is done, if you see, I had total 85 chunks, and every chunk has metadata. Let me display this metadata here. So you have a column called producer, and producer is nothing but Microsoft Word 2016. Then you have creator, which is Microsoft Word 2016. Then creation date is there, and you have title. Sometimes title will be empty because it is not able to extract the title. And then you have subject, Keywords, whatever you have here is also empty, but what we need is to have chunk data, which we will add manually. So you also have modified date, and this is the important key that we need, which is source. And after source, we also have total pages, and after total pages, we also have each page, right? So total, I have total 85 chunks. I have total 85 chunks. So each chunk, the important parameters here are source, total pages, and page. So these are the important field. Now what I need to do is I need to add chunk FAQs, and then I need to add document summary, and then I also need to add chunk keywords. Not just chunk keywords, we also have chunk ID. Chunk ID. So I hope you guys are following. So what we are trying to do is we experimented with two different document parser to extract the raw data from PDF. So this is where when you use PyPDF form, you have this many metadata, but the only important metadata is source, total pages, and page. But as per the architecture of what these guys has built, we need to have our own custom metadata. So for custom metadata, we will use chunk FAQ, which is frequently asked question, then document summary, chunk keywords, and chunk ID. In order to generate this three field, we will use LLM. So I'll come back to the code. So now if you see, in order to generate the custom metadata, I need to use an LLM. And for that LLM, I'm using Samba Nova. And from Samba Nova, the model that we are using is MetaLlama 3. And the model is 8 billion instruct model. So first thing is, how do you get the API key? So you just have to search for cloud.sambanova.ai. And once you do this, you have to click on API keys. And here you just have to create a new API key. And as soon as you create your new API key, you have to come back to collab, click on this particular secrets. And here, what you have to do is you just have to create a new field called Sambanova. So if I copy this and if I paste it here, as you can notice, I've written Sambanova underscore API key, which is the particular value. And then you have to paste your API key over here. So I've already pasted my API key. If I click on this view, as you can see, this is my API key. I've just added a value which is called Sambanova API key and pasted the key in the secrets, which is in the collab itself. So let me run this cell. And now what I'm trying to do is I'm saving my API key of Sambanova inside the environment variable, which reads os.environment Sambanova API key, and then paste your API key. I don't want my API key to be available publicly to everyone. That's the reason why I'm adding it in a secrets. And next, what I'm trying to do is I need to have chunk keyword for every single chunks. And for every chunk, I need to have document summary, which is same. So if you check here, document summary will be same for every chunks, chunk ID, chunk FAQs, and chunk keywords. These three will be unique for every chunks, whereas this is common for every chunk. There is one question here. Okay, what is the use of having document summary for each chunk? All right, so that we already covered, but I will just repeat it. So if you see, whenever we are saving the data inside vector database, let's suppose you have data, and now once you save your data and you want to save it in a vector database, your only main content is vectorized, okay? And whatever metadata you have, you will use it in a payload. So what is the importance of this payload now? Whenever you want to apply any filtering techniques, let's suppose you have 5 PDFs. You have PDF 1, you have PDF 2, you have PDF 3, you have PDF 4, and then you have PDF 5. Now I have a query which is XYZ. Now this XYZ query will fall under PDF1 and it will also fall under PDF2. If you want it to be more personalized and if you want to add filtering, what your this thing will do is, if you notice here, you have something called as query optimizer, which will pick your source identifier. So now, after you add any query, you will have a filter condition. Filter condition is, hey, source of PDF3, right? So now what will happen is, you have your query. Since you added your filter condition, which is source of PDF3, it will pick this particular file. So additional metadata, it's mainly for what you call condition, which is filtering condition. Okay, it's not only for overlapping. There is more advantages of having metadata. Let's suppose you have some keywords. Let's suppose you are generating RFP, right, which is response format for project. If not, you have BRD, you have PRD. So usually, whenever you are generating these reports, and if you want to extract any information from your internal documents, every single domain has different keywords, right? Let's suppose for manufacturing, there are some important keywords. If you want to generate a BRD, which is only specific to manufacturing, that keywords is very important. And you have to filter your, let's suppose you have internal documents. And now what you are trying to do is you want to create a business requirement document. So when you generate this document, you have internal documents. You only need to extract those context. Where is my text? Extract only those context which is relevant to specific keywords. Right? So now what you're trying to do is you're doing filtering based on keywords. This is one way where metadata is very important. And if there is any overlapping, there also you can use filter condition. This is mainly to have more flexibility when you're doing retrieval, right? When you're retrieving any information from knowledge base. So this is the reason why we are adding document summary for each chunk, and we are also adding keywords for every single chunk level. So we are here currently. We have summarizer LLM, and as I said, I'll be using a lightweight LLM model, and the pricing of 8 billion parameter is very less compared to 70 billion parameter models and other models, right? So now what we want to do is, here, if you notice, I'm using Pydantic. Now, why is this important? If you notice the format of, if you notice this format, it is in dictionary, right? So what I want LLM is, I want LLM to generate the final response in a JSON file. So if you want to maintain that consistency, you need to have structured output parsers. So for structured output parsers, we usually use Pydantic. So in this Pydantic, you will define, hey, I need frequently asked question, which is your JSON key. And inside that, you need question and answer. Now then for every single chunk metadata, you need FAQs and keywords. Now if you look at FAQs, I'm using this FAQ, which is your class. So Pydantic is basically used. This is basically used for structured output parsers for LLM to generate the response in JSON. We are using Pydantic base model. So now what will happen? Your FAQ, which is this class, will have response in JSON, which is question, which the LLM will generate. This is LLM generated. And then you have answer, which is LLM generated. So what Pydantic is doing is, it's telling LLM model, hey, I need question, I need answer, and then you're giving description. So now this description will help LLM model to generate the answer. So answer in the sense this value. So this value is there, right? LLM generated is where the description is very useful. Now, if you look at the keys, question and answer is the keys, which is defined by the user. Now, same goes for chunk metadata. Now, what chunk metadata will do? this will use this FAQ logic. So FAQ has to be in dictionary. So you have chunk, you have FAQ. FAQ is in dictionary, which is question, LLM generated. And then you have answer, which is LLM generated. And after you have FAQ, you also have something called as keywords. So now if I use keywords, what is the format of this? It is list. So it is inside list, and then you have string. So you can say keyword one like human rights. Then you will have policy, which is something related to legal laws. So these are some of the keywords. And even FAQs is inside list. So if you check FAQ, whatever you have, this data type is nothing but a Pydantic class, which is in a dictionary. So this is the reason why I added in a dictionary. And then this FAQ is wrapped around list, so which is also a list. So I hope this makes sense how we are trying to create our data. This data is nothing but your additional metadata, and it will be in a JSON format. And in order to get JSON format from LLMs, we are using structured output parsers from Pydantic. And now what you're trying to do is, I have a function which will create the document summary. So if you see, you have a prompt, you are passing certain title, then you have the actual data column or actual data. And based on that, LLM will generate the response, and then you're generating the final response. So this document summary, you're returning it in a string. So if you see document summary, it's been written in the string, and this is common across all chunks. Document summary is common across all the chunks to improve the retrieval process, which is mainly search. And now we are doing the same thing for generate chunk metadata. So if you look at chunk metadata, I have a prompt. This prompt, what it is supposed to do now, it is supposed to use the structured response, and it has to generate FAQs and keywords. So if you see, the response has to be in FAQs and keywords. Why? Because I'm using structured response here. And here is where your chunk metadata is defined. Chunk metadata is your Pydantic base model. And once this is done, what you're trying to do now is you're looping your existing document. And as you see here, I want source, which is already available. If you see, source is already available, page number is already available, and total page is already available. You're just appending document summary, chunk ID, chunk FAQs, and chunk keyword. So this is where that logic is coming into the picture. If you see here, doc metadata, you are adding chunk facts, and then you're extracting the FAQs from the LLM response. So if you see here, chunk metadata, if you look at this variable, what are you doing? You're using a function call. This function call is nothing but this thing. The LLM is generating FAQs and keywords, which is in dictionary. So you just have to extract it outside. So if you see chunk metadata, you're extracting FAQs, and then chunk keywords, you're extracting that keyword. And then you have chunk ID, which you're mainly using it from source. And then you have chunk length. So chunk length is not required, but I'm just adding it for metadata purpose. And what I will do is, since this was using LLM call, what I did is I saved that particular file inside a particular file called enriched documents.pickle file, right? So now whatever metadata I had generated, it is inside this pickle file. So let me upload that pickle file. And now what I will do is, here I saved it. Since it's already saved, what I will do is I will directly load the particular file. So let me load this. So now if I do chunks of 0 dot metadata, so if you see, you have page, you have document summary, then you have chunk answers. So how is chunk answer added? It is in a list, and every single list has question, it has answer, it has question, it has answer. And then you have chunk keyword, which is a list. Is this clear? We are just adding additional fields. And now what we are trying to do is we want to save it in a vector database. I know it's already 1 hour, but just hang in there. This is very important part. So in vector database, what we need to do now is all the chunks, whatever you have to save it in a vector DB. But the first part is your main content will be in your vectors, which will be vectorized. And this is mainly used for schematic search and where you have to index it. And second thing is you have to save, you have to the metadata inside the payload, right? So what are the metadata we'll save inside payload? Document summary, chunk overlap, chunk FAQs, chunk keyword, and page number, and also source. So these are the few metadata that you will be saving in the payload where you can apply filtering techniques. So let me run this. So far, whatever we did, we just extracted the raw data and created multiple metadata. That's it. And now we are just saving that metadata inside a vector database. For that, we are using Qdrant. And in order to use Qdrant, you also need to create embeddings, right? So when you do hybrid search via Qdrant, you can directly use fast embed to create embeddings. So now how do we get this URL and endpoint? So you just have to open cloud.qdrant.io. Let me copy this URL and add it in the text. So I will also attach it in the comments. So in order to get your Qdrant cloud and as well as Qdrant endpoint and as well as API key, you just have to search for cloud.qdrant.io. And as soon as you click on this, you just have to create a free cluster. And once you create a free cluster, you will see your API key and your endpoint. So endpoint starts with HTTPS, and then you have the URL, which will end with a port called 6333. So this is your endpoint, and the API key will be available once you create a free cluster. So let me add this in the text. So you just have to open cloud.qdrant.io and then create your API key. So the first step is click on free cluster. So if I open my account, probably I already have the free cluster created, but let me show it how to create free cluster. So let me delete this. So this is how your Qdrant cloud will look like once you enter. Here, what you need to do is you can enter any name. So I'll just give Uber case study. And now what you can do is you can just click on free cluster. And as soon as you create your cluster, you will see your API key. You have to copy this API key, and then you have to copy this endpoint URL. So if you look at your endpoint URL, it starts with HTTPS and then it ends with a port called 6333. So you just have to copy this entire URL and then come back again, click on secrets, use Qdrant API key and then Qdrant URL, and then paste your value, whatever you have copied. So I've already copied. What I will do is I will use client, Qdrant client, then you have URL and then API key. And then you have collection name. So collection name is indexing should be done only once. Let's suppose you have 5 PDF. Once you save that in a vector database, that is only one time process and it is saved by a unique name called case study. So the next time, if you want to use the same data, you can read it from this collection name itself. Now, if you want to update your data, you can create a new collection name by adding your new data, right? So collection name should be very unique. It can be defined only once. So just make sure whatever you define your case study over here, it's very unique and it's based on the projects that you use. So here I'll define collection name. And now here is where you're defining your embeddings. You have text embeddings, you have sparse embeddings. So for sparse, which is nothing but your keyword search, you're using Qdrant BM25. And for the text embeddings, you're using your vector embeddings, right? So which is from Gina AI. So I'll just run this. And in my case, since the collection is already created, I will not run this cell, but I will just tell what is happening. So I want to create hybrid search for which I need both vector configuration and as well as sparse vector configuration. Sparse vector is nothing but you have zeros and non-zero values. Whereas in dense, it is fixed number of embeddings and you have very limited, probably you have zero values, right? So let's suppose you have dense embeddings which rarely have zero values, which is 0, and it's fixed embedding dimension. So most of the embeddings that you see, whether it is OpenAI or it is Gemini or it is Claude, these are dense embeddings. Now when we talk about sparse embeddings, these are 0 and non-zero values, and basically this is also fixed, but in most of the cases your indices will keep on varying based on the data that you have. So for sparse embeddings, we'll be mainly using TF-IDF or BM25, and there is also BM42 if I'm not wrong. So these are some of the keyword search that you can use using sparse embeddings. So let me copy this, create as a text, paste it here. And once you do that, I want to also apply binary quantization. So basically, even for embedding fast embed, do we need API key? No, you don't need. So if you check this particular code, so when I define text embeddings and sparse embeddings, it is loading the model locally. It's not that much, it's just 1 GB. Even if you're using your own VS Code, you can directly install this particular or load model there. And it's just one time. Once the model is saved, the next time when you run any code, it will not load the model files again. So this is only happening one time, just once. And it doesn't need any API key. You can directly run it. And now vector configuration is done. Your sparse configuration is done. Now coming to the binary quantization. This is very, very, very important. So whenever you are working with large vectors, let's suppose you have 100 documents, you have 1000 documents, it will take too much of time. It will take too much of memory. It will take too much of cost. So in order to bring that cost down, in order to optimize your memory, we will be using binary quantization. So if you are not familiar with binary quantization, I have a blog article on it. So this is my blog article. So how you can build fast multi-document RAG using LangGraph, Qdrant binary quantization, and DeepSeek, which is from Sambanova. So all the tech stacks that you're using today, it's already repeated, but the only thing is the logic is different. So I'll copy this. I will paste it here. So you can check out this particular blog article where you will understand how binary quantization works and why is it important. All right. So now after that is done, here is where the most important part is, and that part is indexing document. So indexing document also needs to be done only once. Index document per collection name needs to be done only once. So based on your data, this will take time. This will take time. So it can be 5 minutes, it can be 10 minutes. If your data is still long, which is 100 PDFs, 200 PDFs, you might expect 20 minutes, 30 minutes just for indexing the documents. So what is happening in the indexing documents? Whatever data you have, you're converting that into vectors, and whatever metadata I need, which has to be searchable. So if you see here, I want to create a searchable text where I'm using my frequently asked question, then keyword text, and as well as I'm saving it in a payload. So this is what I was talking about. If I come back to the Excel sheet, what we did so far, we vectorize the data, and the metadata needs to be saved in the payload so that you can apply filtering condition during the retrieval. So this is done. And now once you add metadata to payload, this will happen during indexing, which has to be done only once. And filter condition and hybrid search, once you save it in a vector database, once it is already available in vector store, then you can use these two things, right? So now what we will do is, let's create the indexing. Indexing is nothing but save your data in a vector database, in simple words. So I'll come back to the code, and if you see here, first you make it searchable, and then you have something called as point struct. Inside point struct, you have to define your vectors. There are two vectors. One is dense, one more is sparse. Why do I need two vectors? For hybrid search. So dense is for vector search, and then sparse is for keyword search. Now, if anyone is not familiar with what dense and sparse and how it works, I do have one slide which is helpful to you guys. I just hope it is in this particular slide. Okay, it's here. So let's suppose your user query is neural network. What keyword search will do is, it will only look for neural networks, but it will miss out information on deep learning and AI. Even though deep learning and AI is very similar to what neural network is, you won't get that information when you do search. But if you look at vector search, if you search for neural networks, it will also return the documents which has AI in it, which has machine learning in it, which has deep learning in it. So vector search is very important, and keyword search is also important when you want to match exact keywords. So what we are trying to do is, we will merge both of them. So we will merge hybrid search and we will merge vector search. This is where you have hybrid search. So now if I come back to the slides, so payload is done. And once you save your data inside payload and vectors, you just have to use upsert. And once it's done, you're just removing certain memories. Like after every batch, I might not need the existing dense embeddings. So I'm just removing it and freeing up the space. So what we are trying to do here is free up the memory and RAM. So we are deleting certain keywords, and then you have GC. GC is nothing but garbage collector. Garbage collector. So indexing happened only once, and I've already saved my data inside vector database. So I will not run this cell. I will directly start from inference. So here what I have is, I have a query called National Education Policy 2020. And what I need to do is, in my data, there are 85 chunks. There are 85 chunks. I need only 5, which are relevant. Right? So that is what K means. I need total 5 documents. And now once you have your query, first thing what you have to do is, you have to convert that into embeddings. So this is very simple. So what we are trying to do now is, we are doing inference. We started off with document processing, where you have your external data, you convert it to chunks, then you have embeddings, you save it in a vector database. We did this part. Now what we are trying to do is, we are trying to build inference engine, where user will ask a query, you will convert that into embedding model, which is your embedding vectors. Then you will search in vector DB. Vector DB will return relevant context. So this relevant context is your key, which is 5. And that context along with query will be going to your LLM, which is in answer generation part. So now if I come back to the code, so what are we doing? We are creating the embeddings of the user query. Then we are creating prefetch. So we use prefetch only when we are performing hybrid search. And now what we are trying to do is, from dense embeddings, I'm taking total top 10. From keyword search, I'm taking top 10. Based on the scores, whatever I have, I will filter out and I will only keep top 5. So this is what we are trying to do in prefetch. And now if you see, you just have to run your query points. This is nothing but search. This is it. We first have to inference. You have your user query, convert into embeddings, use prefetch. And once you have prefetch, you just have to use search. Query points is nothing but search. So when I do search, I want to pass my query, which is in dense vectors. Now, if you look at this parameter, which is very important, with payload equals to true, this means whenever I generate the response, I can see the metadata. I can only see metadata if payload is true. If this is false, I can't see my metadata. So make sure you include with payload to be true, and then limit is k, which is nothing but 5. So now if I run this, and then if I check the length of results points, it's 5. And let me check the 0th index. So if you see, you have ID and you also have payload. So let me copy this payload. And inside payload, I have content. So it's a dictionary. So if I just do keys, you have content, you have source, you have page, document summary, chunk, frequently asked question, chunk keywords, and chunk ID. This is what I wanted. So if you see, I have source, page number, document summary, chunk ID, chunk frequently asked question, and chunk keywords. And this is your metadata, whereas this thing is your main vector content. So content is where you have your actual information. And once this is done, you can just use context, and your context has your main information. So this is what will be passed in your LLMs. What are we doing? Your results.points has all the information. I am only filtering out. I just need what I want, and that's the reason why I'm filtering it out. You can also remove the ID. ID is not required. And here is my information. If you need scores, you can also add scores over here, but scores is not required. Okay, so far that's it from document processing. We saved our data inside vector database. We also inferenced it, where you are directly using a query and extracting the information from vector database. Now, what we need to do is, how do we add filter condition, which is important. Still, we are in inferencing. We still haven't used LLMs yet. I will come to the LLMs part in 2 minutes. So now what we need to do is, you want to make your payload index searchable by just using payload schema type as keyword. So every time if you're using filter, every time you use filter, it should match the exact keyword. So this is very important. You have to match exact keyword, and in most of the cases this is done by hard coding it. So now what I will do is, I will define source, and now let me add the filter condition. So filter condition is nothing but models, filters, must is nothing but it should include. And since I'm using source, what I will do is, I'll use key to be source, and it should match the particular path. So let me print the path of it. Print of 0.source. So this is my path, and I will just paste it in the value. So this is the filter condition now. And then you just have to run results. You can see you have client, then you have query points. It's the same parameters. The only new parameter is query filter equals to filter condition. Then payload is true, which is what I wanted, and then limit is k. Now when you run this, it will only read information from this particular source. You can apply the same logic for keywords. So how do you apply the same logic for keywords? So you have client, then you have create payload index. Now if you see, you have chunk overlap, chunk keywords. The syntax is same. Then you need to have condition. In this condition, you have to define must condition. Then key is nothing but chunk keywords. And if you look at the match, it should match the human rights. So whatever content I extract, it should match human rights, right? So I'll just run this. And now if I check the results, I have some information. Let's suppose I give Virat Kohli here, right? It's just some random number or random string. So now if I check the results, it's empty because I want to extract the information, but I'm applying a filter condition which says a value Virat Kohli, which is an Indian cricketer, and this keyword is not there in my data. So what is my results? It's empty. So this is very important. In most of the times when you are creating PRD documents, RFP documents, you have to give matching keywords so that you get much better retrieval techniques. So just make sure you apply filter condition whenever you have your own custom metadata. All right. So here is where we completed offline document processing. If I come back to the chart, what we did so far is we just completed the bottom part and we also tested this part. Now, which is that part? As soon as we get any user query, we are able to use hybrid search. So we have the code available for hybrid search, and we also have code available for offline document processing. So offline document processing, we don't have to touch now. It's just one-time process. And now what we need to do is we just have to need this particular code of what we did with hybrid search. So this code, if I come back here, whatever you have below inference, which is your query, k value, then these two vectors, prefetch, query points, this is your inference. And this entire code is where you have your retrieval process. So you just have to define a function. Now it's very simple. I'll come to the inference. And for inference, I'm using LangGraph. If people are new to LangGraph, again, you have my blog articles where you can get started with LangGraph. It's very simple. And if you see here, I'm using the same Qdrant client because I need to use the same collection name. So if you see here, all these things, whatever you check in the Collab notebook of document processing, it's happening offline, which is one time. So I will just close this. Now, whatever you run in inference answer generation is where you will dump it in the Slack chatbot, or you will dump it in the Streamlit app, or if you want to create your fast API and React application, this is where answer generation will come in handy, right? So here is just inference, which is real time. This is real time answer generation. Which needs to be dumped on Streamlit or web application or any client. Client in the sense you have Slack chat bot, which is Slack bot, then you have Discord bot, and anywhere else, wherever you want to deploy this application. So if you see, it's the same logic. I'm defining my dense vectors. This will load the model. Since it's happening in the different file, it's only for one time. Then you have collection name. I'm using the same collection name, which is case study. Then I want to define a client. And once I define a client, here, if I come back to the block diagram, I need a small LLM. I need a large LLM. So for large LLM, I'm using Gemini. For small, I'm using MetaLlama, which is 8 billion parameter. And now if you see, you have small LLM and you have large LLM, which is Gemini 2.5. I'll use Pro. And for small LLM, I have Gemini Llama 3.1, 8 billion instruct. So the reason why I had Flash is because you have limited thing. And before this live session, I was running this code. So I just wanted to check with Flash. And during live, I just wanted to convert it into Pro. So now this is done. And here, whatever we have done so far, we are just repeating it from document of offline process. And once this is done, I have the LLM models. And now you have to define your LangGraph state. Now define LangGraph state. So state management is one of the important feature, state management is one of the feature that is LangGraph provides. And now what happens in state management is, what do you typically have in drag pipeline? You have user query, which is your input, and then you also have your context, which is an input. So if you see this white color, right? If you see query is in white color, retrieve context is one color, and then response is one more color. So every single LLM that you have, you want to pass query, you want to pass context, and you want to generate the response. So you have to save your state, context, and response in a state management. So this is what we are trying to do using LangGraph. So now if you check, you are creating a state which is agentic RAG state, and then you are saving your query, then you have context, then you have answer, then you also have filter condition. So if any user wants to apply the filtering condition, you can apply it by it. For optional, this is optional, right? So the major thing are these three, which is query, context, and answer. Filter condition is optional only when you want to use it. And now if you see, the first thing is rewriter agent. So as soon as user asks any query, I'm not using Slack interface, I'm using Streamlit. So if you ask any question over here, the first thing what it will happen is, it will come to the query optimizer, which is my rewriter agent. And here I have the query optimizer part, which will take the query. I'm running the prompt, and then I'm using a small LLM. So small LLM is nothing but Llama model, which is here also, if you see, it is small LLM. So first one is the query rewriter part, and second is the search retrieval. If you look at the code, it is same as what we have done in the previous collab. So if I open offline document processing, and if I come back to the inference part, so if you check the inference, the first step is you have vectors. You have the vectors, and after vectors, what do I have? I have prefetch. Here also, if you see, I have prefetch, and after prefetch, I have query points. So this is common format. You start with converting it into vectors. You have query, convert it into vectors, and then check into vector DB. And after you check into vector DB, you have to return the context. So this is where you are performing search. So this three, whatever you see, is where you are performing search. So for search, we use a function called query points. Right? In query points, you have to give collection name, prefetch for both dense vectors and sparse vectors, and then payload should be true. And I've repeated why payload should be true. The same logic is repeated here. So the limit is 5, then payload is true. If anyone applies filter condition, we will take the filter condition as well. And now you just have to return the context. That's it. So this is your retrieval state, which is nothing but node. And once you have retrieval node, the last and final step of this entire app is your answer generation node. So how do we generate answer generation node? You can just refer to this diagram. Query is passing to the LLM. Whatever context you're getting is passed to the LLM, and then generate the final response. So you have query, you have context, and this context I'm converting list to string and then passing it in a prompt. And once prompt is done, what LLM am I using? I'm using large LLM. So if you come back here and if you check for answer generation, you're using large. And now I'll just run this cell. We have three nodes. One is query rewriter, then we have retrieval, and then we have generate. So now you just have to add that node. Add node, add node, add node, which is your rewriter agent, search retrieval, and then answer generation, and you just have to create a node. Now what you need to do is you have to create an edge between them. How is rewriter connecting with retrieval, and how retrieval is connected to answer generation? So if you want to create or connect the nodes, we need to add the edge. So if you see, we start with rewriter. So we are starting with rewriter, then we are using query. And once you have your query retrieval, then we are going with answer generation. So you are just starting that, add edge, start with rewriter, then rewriter is connected to search retrieval is connected to answer generation. Once you have answer generation, that's the end. I had to run this cell because you can only create state one time. So once I run this, I had to rerun this. And now if I click on graph has to be compiled. So this is the entire workflow. This workflow has to be compiled and I'm saving it in a graph. So this is how my workflow look like. Start, then rewriter agent, then search retrieval, then answer generation. And once that is done, you just have to run that graph. How would you run it? Result equals to graph.invoke. Invoke is nothing but predict. Add your user query and then filter condition. I'm keeping it none. And I'll just run this response. So first it is using rewriter, then search, and after search it will generate the final response. So now if you see, you have print result, and inside result you have answer. So how many fields will result have? It is similar to what you have in agent state. It will have query, it will have context, it will have answer. So you can copy all these three, come here, and I will paste it. So instead of answer, if I give query, so this is the user query. If I give context, so after the retrieval process that you have, what was the context that you have received from hybrid search? So this is that context. And if you check the length of it, it should be 5 because k value was 5. And then you can use answer. So this is what state management is. I want to track my query. I want to track my context. I want to track my answer. So this is it. If you come back to the flow, we completed this entire offline document processing and as well as answer generation. And this is the extra part which I wanted to showcase on how to build LLM as a judge. And as I mentioned, we already created a live session last week, not last week, last month, which is how to evaluate RAG pipeline. You can check out this particular video. In this video, I only told you how to build LLM as a judge. I didn't say how to create a testing data set. So in this file, you have how to create a testing file. So we are using RAGAS. So from RAGAS, you have test set and you can use test set generator. And LLMs, what we need to do is I'm using OpenAI because OpenAI has better diversity in generating data set. Same goes for embeddings. I'm loading it from LangChain. So you can use Gemini from LangChain. You can use Sambanova. You can use Hugging Face. Define your LLMs from LangChain and wrap it around RAGAS. And then I'm reading the file for which I need to generate the data set. So now if you see, I upload a PDF for which I need to generate the data set. And this PDF is from the data that I saved. And then I need to define my embedding models. So this embedding model is from OpenAI. And then chat model is also from OpenAI. The reason why I'm using OpenAI is because it's best when it comes to generating data set. And once this is done, you just have to define your generator. And once you define your generator, just use generate with LangChain docs and the format is same. You have to pass your data. And once this is done, it will create the data set for you. So this data set has user query, then what was the reference context and what was the references. So this way you will have your tracking available. So you have the data set, let people test your platform, get the information from the users, and then keep on appending in this data set, which will also help you in improvising your pipeline, right? So if you see here, you have single op, you have multi op. And I also told you these folks are looking how to build multi-op pipeline as well using chain of RAG, which is one of their future work. So if you check the next steps, they want to implement multi-op reasoning queries using chain of RAG. And this is what you can do after this session. So you have the template ready. I showed you how to create offline document processing. I showed you how to create hybrid search agentic approach. And now what you need to do is add multi-op, then add OCR support. There is no OCR support in this app. So if you can add OCR, that will be much better. And this way, you will know what companies are building and what are their next steps. So this is just episode 1. Episode 2 is on how to convert your text into SQL. Now, what is the challenging part here? The challenging part is every SQL has multiple tables, right? So, what we will do is how to build a text to SQL pipeline which can cater to multiple tables. So, that is the problem statement for the next episode. And we'll try to have slides just like I had today. And the slides link is available in the description after the session is done. So, you can check it out. And for the repo, all the code will be available here. So let me paste it again. So this is the repo link, and we will use the same repo link for all the live sessions. And yeah, do we have any questions? So once this is done, we have LLM as a judge, and you have same context relevance, answer relevance, which we have already covered in the previous live session. So we'll go step by step. We started with evals. Now we have case study episode 1, which is how to build agentic RAG. And I'll tell which company publicly made available of text to SQL. So since most of you are there till the end, I'll show that article as well. So it's from Pinterest. They do have text to SQL. Where is it? Yeah, this is the one. So this is the code that we will be building in the second episode, how to build text to SQL, which Pinterest has built. And they do have a flowchart as well. We see the real time is also connected to the DB. So there are two things here. Are you passing any data here? If you look at the inference, what is happening? You have query, you have your filter condition, then you have dense vectors, then directly prefetch. So if you see, when you're defining client, you're not uploading any data. There is no data when I started. If you look at the real time, you're just defining a client. Client is mainly used for the search technique. So if you see here, you have query, you convert into embeddings. Vector database is involved in the both step. It is also involved in the document processing part. It is also involved in the real-time process. But the only thing is, in document processing, you have actual data. So every time you have data, you have to index it, which has to be only once, right? So indexing is done once. Once it is saved in the vector DB, you are doing only search, nothing else. So what are we doing here? In this code, we are just using client.query points, which is used for search. There is no data. So what is real time? Let's suppose in this app, if I tell user to upload their data, that is what happens real time. But if you look at this app, I'm not telling user to upload a PDF file. I'm just telling him to write a query. So what I will do is, let me ask a query here. So this is the app that I've built. If you see, it is running on localhost, and this is the code, which is app.py, which is again available in the GitHub repo, which I'm using Streamlit. The code is same. If you see, I'm using small LLM, then I have agentic RAG state, then you have rewriter agent, you have search retrieval, then you have answer generation. It is the same thing, but the only thing you are using Streamlit. If I ask that question, so first it is rewriting, and after rewriting search, and once the search is done, then you have answer generation. So typically it takes around 6 to 8 seconds for time being. And now if you see, you have the response, and it also tells from which page number that was extracted. So if you see, for every data that it is generating, it is also having the citation, so from which page number it was generated. But if I ask anything out of context, let's suppose, what is black hole? So black hole is not there in my data. It's, if you see, not enough information available, improve your query with relevant keyword. So here, if you see, it's real time. I'm not telling user to upload their data. Vector database is used only for search, and it's not saving any data. So indexing is happening offline. Real time, it's only for search, and it's simple RAG pipeline. Any other questions? I know we are above time limit. It was supposed to be 1 hour, but we have gone 1 hour 40 minutes. I'll also share these slides in the description. Do we have any other questions, or we'll wind up in 1 more minute? If anyone has any question, you can feel free to ask it. If not, I'll share the Discord URL. So if you check the YouTube video, so here, if you check the description, you have the Discord URL. So for these further queries, what you can do is you can join the Discord, ask your queries over there. And what I will do is I will just add a README file. So if you see in Uber Agentic RAG, there is no README file. I will add the README file with all the details. So if someone who didn't join us live, you can check that README file and get the context. And what you guys can do is, if you want to make any improvements, if you have any issues, make sure you use pull request, make sure you use issues, and do let me know, and I will help you out. All right, this is it, folks, and make sure you stay in touch for the second episode as well. So in second episode, we'll try to build this thing. Where did that go? Pinterest. So this is what we'll try to build in the second episode, which is text to SQL, and it's very interesting problem statement. And the interesting problem statement is the multi-table extraction part, which we will do it in the next episode. Until then, thank you so much for joining in. If you have any queries, do join the Discord server.